iDriveSoCal is brought to you by the very best auto retailers from across Southern California. When it's time for you to buy, or even just kick the tires on the idea of buying, just go to iDriveSoCal.com and click on dealers. iDriveSoCal.com, click on dealers, and get connected. Now, on with the podcast.
The reason we decided to locate the company here in LA is because it is the epicenter of new mobility. Right. Consider us as the Tesla of aircraft. You can make a meaningful aircraft fly fully electric in the 9-passenger range, and that's really what we're focused on. You're looking at regional air travel, short hops. Right now we're in downtown LA. Let's say we wanted to fly over to Catalina, spend a good weekend over there. We'll be test flying a full-size aircraft next year.
Welcome to iDriveSoCal, the podcast all about mobility in the automotive capital of the United States, Southern California. I'm Tom Smith, and joining me today is the co-founder of Ampere, Kevin Nortker. He's co-founder and CEO, and what's significant about this particular podcast is that while I always tag it the automotive capital of the United States, we are talking mobility, but today we're talking about very exciting electric airplanes, and that is the Ampere company that Kevin co-founded, and he and his team are developing an electric airplane right here in Southern California, specifically in Los Angeles, in the Los Angeles Clean Tech Incubator. Kevin, thank you so much for joining me.
Yeah, it's my pleasure. Thanks.
In your words, what really is Ampere?
Well, we founded Ampere on that question of what is the highest performance aircraft that's uniquely enabled by electric vehicle technology. So we are taking all of the great tech that was developed for automotive electric vehicles, and we're applying it into aviation. So consider us as the Tesla of aircraft.
The Tesla of aircraft. The idea came from
my co-founder, Corey Combs.
Tell me a little bit about the team and how you guys came together.
We had a co-founding team of 3. So that was Corey, Ryan, and myself. Corey and I had worked together back at Northrop Grumman starting in 2009, where we were doing some advanced technology research and development. We were a real solid R&D team together there. Went our separate ways after a few years. I stayed at Northrop. Corey went to scratch his clean tech itch and did a startup internationally for a while. And then in 2015, he'd been watching the automotive electric vehicle and aircraft technology space for a while, looking to see where could they merge and when was technology really ready for the electrification of air travel. And so he reached out to me late 2015, convinced me to leave my comfortable job at a big company and asked me to co-found this company with him. And we brought Ryan on as well and started in March of 2016. Since then, we have a team of 9 that we've built up, brings experience from big companies like Northrop Grumman, GE, and ABB, high-tech startups like SpaceX and Faraday Future, and research institutions like Stanford, Caltech, and USC.
So you're all engineers?
Most of the team is engineers, but we do have some business development. For example, our co-founder Ryan has a background in mathematics and economics. He's worked at various banks and trading firms in the past, as well as some startups.
Were you all in school in the back of your mind individually, hey, startup thing might be something that is going to attract me down the line?
I think that you do have that little spark inside of you all that time, right? But I did spend 7 years at Northrop before starting a company. So it took me quite a bit of time to get there. Corey had also thought about starting a company while he was in school. He went to Stanford. And so that's most people coming out of Stanford have that bug at least a little bit. But he...
prereq to go there.
Yeah, right. And so he went and joined a startup in about 2012, 2013 timeframe, working directly for their CTO in order to gain the requisite knowledge and experience to where he was comfortable starting a company himself. And Ryan also had worked at a startup previously. So all of us had that idea, though we're all first-time founders in this case.
So you get the idea, but now you're here and you're a portfolio company of LA Clean Tech. Before we get to what that means from a LA Clean Tech perspective, how did you come to the point of being here?
You make a commitment to yourself that you're willing to go through with it, right? Then a commitment to your co-founders. We put in money out of our own pockets to get started because you got to start somewhere. And then then what we did was we rallied the troops. Well, we all had jobs. Corey was in Beijing, Ryan was in Chicago, and I was here in LA. And so by September of 2016, we're all three of us full-time down in Temecula, California, which is where we founded the company. It was officially in Temecula.
Why Temecula?
Both of my co-founders grew up there. So we were able to bootstrap. I was paying the most for rent per month, and I was paying $400. So and free office space goes a long way as well. So we really were able to carry the company on a low burn rate for those first few months while we were kind of figuring out how do you go about achieving this big vision for electrifying air travel.
Batteries are so heavy in cars and hybrids. How are we going to put wings on those things, not to mention put people in the fuselage that are connected to the wings and make the whole thing? I mean, how does that work? What are your biggest challenges?
Well, there are a lot of questions in that one. We'll unpack that a little bit. So you started by asking a bit about how do you get to this, right? How do you get to the decision to make a passenger aircraft versus a small drone, right? Electrification can take a lot of different forms. We started, back when we were in Temecula, working on this concept of the most advanced airplanes out there. You're looking at like the Elon Musk jet. Your vertical takeoff and landing, can you achieve that? Well, we were asking those questions. Can you go supersonic electric? We're asking those questions too. And there's this balance between, as you stated, the limitations of electric vehicle technology. That's what is the energy density of your batteries? What's the power available with electric motors that are currently available today? And then what kind of aircraft could fly a meaningful mission using that technology? And for the first few months, we were exploring those questions. And it's an intricate dance and interplay between the technology viability, the market readiness and need, and the regulatory risks that go into it. But ultimately, taking technology and the most advanced battery cells that are available today, you can make a meaningful aircraft fly fully electric in the 9-passenger range. And that's really what we're focused on right now.
Fully electric can fly 9.
9 people, yeah. So you're looking at regional air travel, short hops. Right now we're in downtown LA. Let's say we wanted to fly over to Catalina, spend a good weekend over there. You'd fly in a 9-passenger turboprop aircraft. Or if you went over to Hawaii and you wanted to hop between islands, you very well might fly in a turboprop aircraft of this size category. That's the first market we're going after.
How soon is that going to be a reality?
We'll be test flying a full-size aircraft next year, and we will anticipate having a certification, so that's FAA approval of our retrofit into an existing airframe by the end of 2020. And so by 2021, you could be buying a ticket on one of these planes.
Let's go back to challenges. Is the battery technology your biggest challenge?
The battery technology is the biggest limitation to the range in which we can fly. You can get plenty of power out of large battery packs. That's not really where the challenge comes from. It is determining how far can you fly fully electric. Or the open question for many is, do you have to be hybrid electric in order to fly a meaningful range?
Did I read that you guys are going to do hybrid first, or are you going to go fully electric first?
Fully electric first. We have concepts for hybrid, and we are working on developing those systems. However, our baseline and first flights will be fully electric.
And electric vehicles are too quiet, or can be too quiet. Obviously, air travel is extraordinarily noisy. But I know on your website, you said you're cutting down noise. You're cutting down, obviously, the carbon footprint. What is it going to sound like?
It's actually wonderful. The passenger experience is going to be great. There are aircraft out there currently that fly fully electric, and those are trainer aircraft. And I watched a video recently where they showed 2 people flying one of these aircraft talking without headphones, without headsets.
Where are their electric aircraft currently?
Oh, they're actually kind of finding their way into a number of training schools. So coming out of Slovenia, there's a great company named Pipistrel, and Pipistrel is building 2-seat and then 4-seat trainer aircraft. They're currently certified under light sport, which makes it difficult to operate in the United States because light sport aircraft aren't approved by the FAA to be electric. However, these trainers are what people can currently fly kind of as a hobbyist would fly or for general aviation. But yeah, they're at that size category. They're currently aircraft ready to fly and being delivered. So go up to Fresno. There's a flight school there that is looking to operate, I believe, 4 of these aircraft. And even down here in Compton at the Experimental Aircraft Association, they have a few of these trainer aircraft ready to go. They're just waiting on the FAA's certification.
When is that expected?
Well, if they're certifying under light sport aircraft, I wouldn't hold my breath. But if they can figure out how to get it under Part 23, then the laws are in place to allow for that certification. It's just a matter of them actually going through the steps.
So there's electric aircraft out there, but it's an FAA thing. We can't do it. We can't fly them in the United States right now.
You can fly them, but not commercially.
I own one. I have a strip of land in the Midwest and a runway. I have the means to buy an electric aircraft. Can I bring it over and fly it legally?
There's a nuance there that I'm trying to figure out. But that's very near term. I mean, you can fly them in Europe. They're already flying them. There are aircraft on the ground here. I don't know the restrictions on those particular aircraft.
But it's happening. It's coming. It's not a maybe kind of thing. If you guys here at Ampere can figure it out.
Yeah. Well, I mean, the FAA put into law the ability to certify an electric aircraft. Previously, the regulatory framework did not allow for electrification. It specified things like the size of your combustion chambers. Now, that's not very conducive to an electric motor, which has no combustion.
Were those just old rules that needed to be rewritten because they were outdated, or was there a lobby behind it?
Those were old rules that just needed to be rewritten.
Okay, so it didn't take too much to say, hey, this is old, we need to adjust it. There wasn't a body out there saying, no, we need to keep it just as it is.
No, it only took about 10 years, though. So they recognized that the rules needed to be updated. There's a organization out there called the General Aircraft Manufacturers Association that kind of led the charge on updating these rules, and the FAA has, quickly as they could, implemented those rules. However, it is a lengthy process to make new laws in the United States.
With electric aircraft already in existence in Europe, then that means that there's other companies that are doing exactly what you guys are doing, right?
Similar, not exactly what we're doing, though.
Okay, so it leads me to what is your advantage? What is your differentiator?
Talking in very general terms here.
Please.
We're taking a very pragmatic approach in how we are approaching the market and what market we're taking on. If you look at other players in the electric aircraft industry, there are basically three types of aircraft that we would see in the near term. The first is those trainer aircraft. So these are either brand new airframes or repurposed airframes that are turned electric in order to support the training of new pilots. So these are small airplanes with short endurance. Most of them are full electric. You also have in that category kind of general aviation aircraft that individuals could purchase and fly on their own. You have a second category of people developing electric aircraft and hybrid electric aircraft, which is in your vertical takeoff and landing urban air taxi. So that's
the flying car kind of thing, right?
Flying car is what
That's what I'm talking about. That's why we're sitting here. That's why I want to talk to you. Tell me when I get my flying car.
Yeah, well, I mean, if you listen to what they're saying, they'll be demonstrating and flying by 2020. However, to be certified in order to actually fly passengers commercially, it'll likely be a number of years later than that. And to be at full scale, when you're looking at, instead of calling an Uber car, you would call an Uber air taxi, and they'd be flying in mass. I anticipate it'll be a bit longer.
Is that essentially going to be, is it going to look like the drone that I see neighbors flying around for fun, but just a lot bigger?
There are some that look basically like scaled up drones. However, there's some optimizations that you would make when you're actually looking to carry significant weight and fly longer distances. So imagine a drone where you had two wings, one in the front and one in the back, and you had propellers, like those 4 propellers or maybe more of them, and those wings tilted up. You're able to take off like a helicopter, then you tilt forward, and then the wing actually catches the air, so then you fly more efficiently than a helicopter normally would. And so there are a handful, more than a handful now, of companies that are approaching that urban air taxi use case. And we have decided to not tackle that use case. We did found the company considering those as opportunities, but for various reasons have decided to focus on more conventional regional air travel instead.
You guys have the vision and the plan of actually becoming an aircraft manufacturer.
That could happen.
Or
partnering.
Licensing your technology, partnering.
So what we're developing right now is the propulsion technology which would enable these aircraft. When you look at the future of electric aircraft, even for regional air travel, new airplanes make a lot of sense. You can integrate propulsion units, whether it's propellers or ducted fans, in new ways that you previously couldn't do with a combustion engine. And so those integrations make you fly more efficiently through the air with less drag, effectively, and more efficient use of your power, more efficient integration of your battery packs. So we do see a future for new build airplanes. Our first step is to partner with with aircraft manufacturers who want to electrify their existing planes and their potentially near-term new build aircraft. And we also have some IP, as you've seen on our website, the Tailwind aircraft, which has a unique integration of a propulsion system there.
So the Tailwind that I see on your website, that may or may not be what we wind up hopping in to fly over to Catalina or from island to island in Hawaii?
It very well could be, but in the more near term, you're going to fly on an aircraft which from the outside looks very similar to or identical to the aircraft that's already flying those hops today. It's just that rather than being a loud turboprop, it'll be a quiet electric system.
If it's a retrofitted plane that was built for a combustion engine, what other things do you guys have to change high level in order to make it all work?
You have the areas that you store fuel. You have all the fuel lines. You have all of the avionics or other or hardware in the cockpit that display information about your combustion engine. Maybe that's the amount of fuel you have left or the RPM of the engine itself. You then have the components directly related to the engine, whether that's the engine or various the cooling systems, thermal systems. So we have to redesign those aspects, the aspects of the aircraft which are unique to enabling the combustion engine, pull those out and re-engineer from the kind of first principles on what kind of thermal system is required to dissipate heat generated by your electric system rather than the combustion system. Electric motors don't produce nearly as much heat. We also have to look at if you're removing fuel and putting batteries in, where do you put those batteries?
Well, it sounds like you're going to save a lot of weight, right? Without fuel and without all the extra technology that we said we're pulling out.
Sure. Well, we'll save weight and then we'll fill it up with batteries.
But is it going to be more? Because it just seems to me like, gosh, these batteries are so darn.
So they're definitely heavy, right? The battery energy density, as we spoke about, is the limiting factor for how far you can fly. Fundamentally, these airframes are certified for a certain takeoff and landing weight. So you are unable to fly the aircraft if it weighs more than a certain amount when it takes off or lands. We have to stay within those bounds. So the aircraft won't be heavier. It'll just be a question of how many batteries can you fit in, given a certain payload requirement, payload being passengers or cargo, and how far can you fly, given that amount of batteries. That's the design game that you play. And what we've found is a solution which meets the needs of the initial target market. Now, these are short hop flights, but is achievable given a meaningful payload size and meaningful range on existing planes retrofit with electric.
What are some of the models that are currently out right now flying that you guys are targeting and saying, we think we can change that plane to fly electric by a means of what we're working on?
So we have done a thorough analysis of just about every plane that's out there in the size category, and we don't talk about specifically which ones we've chosen. Sorry about that.
Okay. So let's go back to the LA Clean Tech. You guys, and the fact you're a SoCal startup. And by the way, did you guys just happen to be here? Is there any like Howard Hughes is here? And there's a lot going on. And you got Northrop here. You got Raytheon.
Northrop, Raytheon, Boeing, Lockheed, SpaceX, Virgin Galactic, Tesla, Faraday Future, JPL. You got a lot of great industry around here.
Yeah.
And so the
Faraday's that's a car though, right? That's not
electric vehicle. Yeah.
Right.
So if we're developing an electric propulsion system, you've got to imagine we need electric propulsion engineers.
Sure.
Whether the motor's turning a propeller or a wheel, some of the underlying systems are analogous or similar between the two.
Okay.
Yeah. So you asked why we located ourselves in Los Angeles.
I mean, you said your partners are from Temecula. So.
Yeah, they're from Temecula. I've spent the last 13 years here in LA. I went to Caltech and got my mechanical engineering degree, worked while I was a student at JPL, the Jet Propulsion Laboratory for NASA. I spent 7 years at Northrop Grumman here in Los Angeles. We are well connected into the aerospace industry here, and ultimately the reason we decided to locate the company here in LA is because it is the epicenter of new mobility.
Right. For all those reasons. You were here because it was here, and only makes sense to stay.
Yes.
So you put your own money into the company.
Yep.
Do you want to say how much?
No, thank you.
Okay.
We did put a sizable amount from each of our savings, though.
Okay. And then how did you make your way to LA Clean Tech Incubator?
Yeah, so when we founded the company, we were up in LA. We were invited to an event here at the incubator, and we had heard that they had a great advanced prototyping center. So where you could actually take your ideas from the computer and build them with water jet cutters and CNC machines and other tools that are available.
Like 3D printer?
3D printers as well, yeah. And so we came for a tour, and this is back just a few months after founding the company. And we knew that we were located in Temecula and it wasn't convenient for us. However, once we decided to move the company back to Los Angeles, we were doing a study of where should we move. Should we move to the South Bay where many of the aerospace companies are? Should we move up to Pasadena where my Caltech network and JPL are located, as well as a number of other aerospace startups? We ultimately decided that the Los Angeles Clean Tech Incubator had the resources that we needed in order to help us both grow the company in a business sense.
And what does that deal look like? Is it different for every company, or is it cookie cutter for, hey, you come in, we take this percentage of the company and we give you these resources and this money and away you go? Or how does it work?
Yeah, so based on the stage of the company, there is a slightly different form of the deal, but it includes the incubator providing resources to the companies in exchange for equity in the company. That amount of equity changes from company to company, though they're pretty set templates for how much they expect to take there. And the contributions, as you could imagine, change from company to company. Everybody gets an executive in residence assigned to them where it's kind of a mentor role helping you through the tough decisions and ensuring that you're moving correctly.
So you're not going to disclose the details of that either?
I can't. Sorry about that.
That's okay. What does the next 3-5 years look for you guys, and do you even think beyond that? Is it realistic to think beyond that?
Yeah, so I was having this conversation just about an hour and a half ago with my co-founders. We have financial models that project out to 2028.
Okay.
But how realistic is it for a company that's less than 2 years old to project out 10 years? So we have to have an eye for the future, right? That's why you're an entrepreneur, because you're imagining what the future could be. And we have to be optimistic and realistic about what those futures look like. However, there's immense uncertainty in that future. So as you go to the nearer years, right, we'll say in the 3-year time frame, it's a very clear path for us, because by the end of 2020, we'll be getting certification on our first product. So the path to achieve that milestone for the company is well set through our first flight next year, the production engineering of our system, and then certification of that system. That is in the 3-year horizon. Contingent on the success of that activity, which we believe will be very successful at it, that opens up a business opportunity for the operation of a profitable business in that regard, but also gives us a foundation to then go and pursue new build airplanes. As we talked about, though we're pursuing retrofits initially, airplanes like the Tailwind are pretty exciting. And we do see that in the 5 to 10 years out, it will make sense for companies and operators, those are airlines, to consider new build aircraft rather than the retrofit aircraft. And so we'll be applying resources into that, either in-house development or partnerships with airframers.
The competition, we touched on it before, but I'm just sitting here wondering, the Boeings of the world, the Airbuses of the world, they look at you guys and say, hey, we're going to support you and help you, or they look at you and say, we're going to crush you?
The large companies, there's an exciting announcement recently that Airbus, Siemens, and Rolls-Royce plan on demonstrating a electric or hybrid electric 150 passenger aircraft in the 2020 timeframe. Now, Airbus has already made moves to demonstrate a 2-seater aircraft, and then they began developing a 4-seater hybrid aircraft, electric, and canceled that project. And if you look at the big players like the Airbuses and Boeings, they don't build small planes. They're positioning themselves for the inevitable future where electrification, or bringing hybrid electric, emerges into those large aircraft, the 150 seat. I'm very excited for them to do that demo, because when they're demonstrating demonstrating their first prototype in 2020. We'll be achieving certification on our first product. It'll be great marketing for us.
Yeah, that's true. I said I threw the big ones out. What about the Cessnas of the world or the Honda, right? The Honda got into the Honda Jet line not too long ago.
Absolutely. So each of these companies, we anticipate and have talked to some of them that they are interested and curious about the future of electrification, don't necessarily have expertise in it, and aren't necessarily strategically aligned to go at it on their own. We have had conversations with OEMs, airframers, who are looking to companies like Ampere to electrify their aircraft.
Your residency here, can you even say how long that might be?
At Los Angeles Clean Tech Incubator? Yeah. So this incubator is unique in that it actually gives us quite a bit of time that they'll be supporting us. So it's a 5-year agreement.
Long runway.
Yeah, long runway here.
Unintended.
That's great. Yeah, so we're happy that we have that amount of time to be a portfolio company here at the incubator, and we'll see if and when we outgrow the space. Certainly, we don't anticipate building our airplanes in the incubator itself or in the wonderful warehouse across the street, but we do anticipate having a presence here.
Kevin, thank you so much. I appreciate your time and joining me here on iDriveSoCal. Again, the company is Ampere, and they are commercial electric aircraft right here in Southern California in Los Angeles. They're a portfolio company of the LA Clean Tech Incubator. Thanks again to my guest, Kevin Nortker of Ampere, for joining me today. You can follow Ampere at Ampere Inc. on Twitter. For iDriveSoCal, I'm Tom Smith. Thank you so much for listening. Until next time.